Hello grade 10, how's your day today? I am Sir Rainier, your teacher guide for Science 10 Quarter 2 Module 2. I am here to help you understand your self-learning module, and here are a few reminders to help you succeed in studying this week's video module together with the most essential learning competencies. Set a conducive learning space. Seek assistance from your parents or guardians. Take down important concepts. List questions you would like to ask from your teacher and reflect and apply the concepts that you have learned. Here are the most essential learning competencies for Quarter 2, Module 2. Compare the relative wavelengths of the different forms of electromagnetic waves and solve problems involving wavelength, frequency, and energy of an EM wave. Now, let us know the expectations and outcomes. 1. Solve problems involving wavelength, frequency, and energy of an electromagnetic wave. And 2. Compare the relative wavelengths, frequencies, and energies of the different regions of electromagnetic waves. Now, let us move on to our pre-test. Please prepare your pen and paper for your answers. You will be answering 10 items and choose the best answer from the options. Are you ready? 1. Which of the following electromagnetic waves has the highest energy? A. Gamma rays. B. Microwaves. C. Radio waves. D. X-rays. What unit of measurement is used to express the frequency of the wave? A. Hertz. B. Joules. C. Meters. D. Seconds. 3. Which of the following correctly lists electromagnetic waves in the order from the longest to the shortest wavelength? A. Gamma rays, ultraviolet, infrared, microwaves. B. Microwaves, ultraviolet, visible light, gamma rays. C. Radio waves, infrared, gamma rays, ultraviolet. D. Radio waves, infrared, visible light, X-rays. 4. How is the wavelength of infrared differs from the wavelength of ultraviolet waves? A. Longer. B. Shorter. C. The same. D. None of the above. 5. What is the main difference between a radio wave and a light wave? A. Speed. B. Wavelength. C. Both A and B. D. None of the above. 6. Which of the following shows the correct order of electromagnetic waves from lowest to highest energy? A. X-rays, visible light, microwave. B. X-ray, gamma rays, visible light. C. Ultraviolet, visible light, gamma rays. And D. Microwave, visible light, gamma rays. 7. What is the frequency of radio waves with a wavelength of 20 meters? A. 1.5 times 10 to the 7th Hertz. B. 15 times 10 to the 8th Hertz. C. 0.15 times 10 to the 5th Hertz. Or D. 150 times 10 to the 7th Hertz. 8. If the frequency becomes higher, what becomes the energy of a wave? A. Higher. B. Lower. C. Neither stays the same. D. None. 9. What is the wavelength of the wave with the frequency of 3 times 10 to the 9th Hertz? A. 1.0 times 10 to the negative 1 meters. B. 1.0 times 10 to the negative 2 meters. C. 1.0 times 10 to the 2 meters. And D. 3.5 times 10 to the 1st meter. 10. Which of the following colors of light consist of the longest wavelength? A. Red. B. Blue. C. Yellow. D. Violet. Answer the same pre-test questions in this Google form to know your score. Visit the link below, Google form link, Science 10 Quarter 2 Module 2. Click the link found on the description area of this video module. Looking back, let us review some terminologies related to last week's video module. Grade 10. These are the terminologies in electromagnetic wave theory. Wave. It is a disturbance that travels through space and time and is usually carrying energy. Electromagnetic wave. A wave that does not need any media to propagate and produced by accelerating charges. Transverse waves. It is a moving wave whose oscillations are perpendicular to the direction of the wave or path of propagation. Particles. These are objects that move from one place to another. The following are scientists who have contributed to the development of the electromagnetic wave theory. Michael Faraday. He discovered the electromagnetic induction. Hans Christian Ørsted. He discovered the connection of electricity and magnetism. James Clerk Maxwell. He discovered the existence of electromagnetic waves. Now, let me introduce the topic for this video module number 2. All EM waves can travel through a medium, but unlike other types of waves, they can also travel in a vacuum or empty space. The electromagnetic waves travel in a vacuum at a speed of 3 × 10⁸ meter per second and denoted as c, or the speed of light. The wave's speed, frequency, and wavelength are related by the following equation. C is equal to lambda times f. That is formula number 1, where c is the wave speed or speed of light expressed in meters per second, f is the frequency expressed in hertz, and lambda is the wavelength expressed in meters. Since all of the EM waves have the same speed, which is equal to the speed of light, as the wavelength decreases, the frequency of the wave increases. It means that the wavelength of a wave is inversely proportional to its frequency. Again, as the wavelength decreases, the frequency of the wave increases. As the wavelength increases, the frequency of the wave decreases. Every type of EM wave carries a specific amount of energy denoted by capital letter E, the discovery of which was made possible by a scientist named Max Planck. He was able to calculate the exact multiplier to get the energy of a photon carried by an EM wave. It is called the Planck's constant, with a value of 6.63 × 10⁻34 joules second. The constant value can be used to get the energy of an EM wave using this formula. E is equal to h times f, formula number 2, where E is the wave energy in joules, h is the Planck's constant in joules second, and f is the frequency in hertz. Combining formula 1 and 2 can give you the equation below that you may use in computing wave energy. Formula number 3 is E is equal to h times c divided by lambda, where E is the wave energy in joules, c is the speed of light, that is 3 × 10⁸ meter per second, h is the Planck's constant in joules second, and lambda is the wavelength in meters. Now, we are going to move to the next part of the video module, solving word problems involving EM waves. Remember these 4 steps in problem solving. Step 1. Write the given. Step 2. Write the unknown. Step 3. Write or derive the formula. And step number 4. Solve or final answer. Presenting solving word problems involving wavelength and frequency of a wave. Sample problem 1. What is the frequency of radio waves with a wavelength of 30 meters? Step 1. Write the given. C is equal to 3 × 10⁸ meter per second, and that's the speed of light, and lambda, which is the wavelength, is 30 meters. Step 2. Write the unknown. F is equal to blank. Step 3. Write or derive the formula. The formula that we are going to use is F is equal to C divided by lambda. Step 4. Solve or final answer. Frequency is equal to 3 times 10 to the 8 meter per second divided by 30 meters. And the answer is 1 times 10 to the 7th hertz. And that's the final answer. Sample problem number 2. Violet light has a wavelength of 4 times 10 to the negative 12 meters. What is the frequency? Step 1. Write the given. C is equal to 3 times 10 to the 8 meters per second. And lambda is equal to 4.1 times 10 to the negative 12 meters. Step 2. Write the unknown. Frequency is equal to blank. Step 3. Write or derive the formula. F is equal to C divided by lambda. Step 4. Solve and final answer. F is equal to 3 times 10 to the 8 meters per second divided by 4.1 times 10 to the negative 12 meters. Final answer. F is equal to 7.31 times 10 to the 19 hertz. Step 3. What is the wavelength of a wave with a frequency of 3 times 10 to the 11 hertz? Step 1. Write the given. C is equal to 3 times 10 to the 8 meters per second and F is equal to 3 times 10 to the 11 hertz. Step 2. Write the unknown. Lambda is equal to blank. Step 3. Write derive the formula. Lambda is equal to C divided by F. Step 4. Final answer. 3 times 10 to the 8 meters per second divided by 3 times 10 to the 11 hertz. Lambda is equal to 1 times 10 to the negative 3 meters. Grade 10. Answer the following problems. Prepare your ball pen, paper, and calculator. Number 1. Calculate the wavelength of radiation with a frequency of 8 times 10 to the 14 Hz. Number 2. A helium laser light emits with a wavelength of 6.33 times 10 to the negative 7 meters. What is the frequency of the light? You may submit your answers on the given Google form link found on this video episode. Proper feedback regarding your answers will be done through your registered email. Thank you. Solving word problems involving energy and the frequency of a wave. Sample problem 4. Calculate the energy of a photon of radiation with a frequency of 8.5 times 10 to the 14th Hz. Step 1. Write the given. F is equal to 8.5 times 10 to the 14 Hz. And H is equal to 6.63 times 10 to the negative 34 joules second. Step 2. Write the unknown. Energy or E is equal to blank. Step 3. Write or derive the formula. E is equal to H times F. Step 4. Solve or final answer. E is equal to 8.5 times 10 to the 14 Hz multiplied to 6.63 times 10 to the negative 34 joules second. Final answer. E is equal to 5.64 times 10 to the negative 19 joules. Sample problem 5. What is the frequency of a photon with an energy of 9.2 times 10 to the negative 7 joules? Step 1. Write the given. E is equal to 9.2 times 10 to the negative 7 joules. H is equal to 6.63 times 10 to the negative 34 joules second. Step 2. Write the unknown. F is equal to blank. Step 3. Write or derive the formula. F is equal to E divided by H. Step 4. Solve or final answer. F is equal to 9.2 times 10 to the negative 7 joules divided by 6.63 times 10 to the negative 34 joules second. Final answer. F is equal to 1.39 times 10 to the 27 Hz. Answer the following problems. 1. Calculate the energy of a gamma ray photon whose frequency is 5.02 times 10 to the 20 Hz. Number 2. What is the wavelength of a light whose wave energy is 4.9 times 10 to the negative 15 joules? You may submit your answers on the given Google form link found on this video episode. Proper feedback regarding your answers will be done through your registered email. Thank you. Solving word problems involving frequency, energy, and wavelength of a wave. Sample problem 6. Determine the wavelength of a photon with an energy of 6.0 times 10 to the negative 19 joules. Step 1. Write the given. C is equal to 3 times 10 to the 8 meters per second. H is equal to 6.63 times 10 to the negative 34 joules a second. E is equal to 6.0 times 10 to the negative 19 joules. Step 2. Write the unknown. Lambda is equal to blank. Step 3. Write or derive the formula. Lambda is equal to H times C divided by E. Step 4. Solve our final answer. Lambda is equal to 6.63 times 10 to the negative 34 joules second times 3 times 10 to the 8 meters per second divided by 6.0 times 10 to the negative 19 joules. Final answer, lambda or the frequency is equal to 3.32 times 10 to the negative 7 meters. Sample problem 7. Calculate the energy of a photon with a frequency of 3.9 times 10 to the 7 meters. Step 1. Write the given. C is equal to 3 times 10 to the 8 meters per second. H is equal to 6.63 times 10 to the negative 34 joules second. And lambda is equal to 3.9 times 10 to the 7 meters. Step 2. Write the unknown. Energy or E is blank. Step 3. Write or derive the formula. E is equal to Hc divided by lambda. Step 4. Solve our final answer. E is equal to 6.63 times 10 to the negative 34 joules second times 3 times 10 to the 8 meters per second divided by 3.9 times 10 to the 7 meters. Final answer, energy or E is equal to 5.1 times 10 to the negative 19 joules. Answer the following problems. 1. Calculate the frequency of a photon whose energy is 3.33 times 10 to the negative 13 joules. Number 2. What is the energy of a photon of radiation with a frequency of 8.5 times 10 to the 14 Hz? You may submit your answers on the given Google Form link found on this video episode. Proper feedback regarding your answers will be done through your registered email. The next part of this video module is the electromagnetic spectrum. Electromagnetic spectrum is the continuous range of electromagnetic waves arranged in the order of frequency and wavelength. It is divided into regions based on the frequency or wavelength interval. You will see the electromagnetic spectrum from left to right, radio waves, microwaves, and infrared that are all non-ionizing. At the middle is the visible light. At the right side, ultraviolet, X-rays, and gamma rays are ionizing. You can pause this video for a while to take a look on various examples of EM waves. On this picture, the visible light is separated into bands of colors with different wavelengths and frequencies. It is arranged in decreasing wavelengths and increasing frequencies. Do you still remember the 7 colors of the rainbow, the Roy G. Biv? The red, orange, yellow, green, blue, indigo, and violet. Red has the longest wavelength and the lowest frequency, while the violet has the shortest wavelength and the highest frequency. On this table 1.1, you will notice the electromagnetic waves, wavelength, frequencies, and energies. As you go downwards from radio to gamma rays, the wavelength values in meters are decreasing, while the frequencies in hertz and energy in joules are increasing. The following are the generalizations for this video module. The numerical values of wavelengths from radio going to gamma rays are decreasing. It means that the radio waves have the longest wavelength and gamma rays have the shortest wavelength. The numerical values of energy from radio going down to gamma rays are increasing. It means that the radio waves have the lowest energy and gamma rays have the highest energy. The frequency of electromagnetic wave spectrum is directly proportional to the energy and inversely proportional to its wavelength. check your understanding. Instructions. Letter A. Arrange the electromagnetic spectrum in decreasing wavelength and increasing frequency. Number each EM wave from 1 to 7. Number 1 is the longest wavelength and lowest frequency. We have visible light, infrared, X-ray, radio wave, gamma ray, ultraviolet, and microwave. Instruction for letter B. Arrange the colors of the visible light in decreasing wavelength and increasing frequency. Number each color from 1 to 7. Number 1 is the longest wavelength and lowest frequency. Yellow, red, violet, indigo, blue, green, and orange. Answer the same check your understanding questions in this Google form to know your score. Kindly visit the link below found on the description area. Get ready your ballpen and paper for this post-test. 1. Why do gamma rays have the greatest penetrating energy? A. Because they have lowest frequency. B. Because they have the longest wavelength. C. Because they have highest frequency. D. Because they have longer wavelengths than X-rays. 2. What is the wavelength of a photon with an energy of 5.1 times 10 to the negative 19 joules? A. 1.9 times 10 to the 7 meters. B. 2.9 times 10 to the 9 meters. C. 3.9 times 10 to the 7 meters. D. 4.9 times 10 to the 9 meters. 3. Which of the following is not an electromagnetic wave? A. Infrared radiation. B. Light wave. C. Sound wave. D. Radio wave. 4. What happens to the frequency of a wave when its wavelength is doubled? A. Doubled. B. Halved. C. Tripled. D. Unchanged. 5. How are electromagnetic waves produced? A. Any disturbance. B. Currents. C. Moving charges. D. Voltage source. 6. Which of the following colors of light has the shortest wavelength? A. Red. B. Blue. C. Yellow. D. Violet. 7. Which of the following best describes the wavelength, frequency, and energy of red light? A. Long, low, low. B. Short, high, high. C. Low, high, low. D. Short, low, high. 8. What is the wavelength of the wave with the frequency of 3 times 10 to the 9 Hz? A. 1.0 times 10 to the negative 1 meters. B. 1.0 times 10 to the negative 2 meters. C. 1.0 times 10 to the positive 2 meters. D. 3.5 times 10 to the 1 meters. 9. The spectrum of light is arranged according to decreasing wavelength and increasing energy. Among the colors of the spectrum, which has a higher energy than red but less than blue and yellow? A. Violet. B. Yellow. C. White. D. Orange. 10. Which of the following best states the difference between blue and indigo light in terms of frequency? A. Indigo has greater frequency. B. Blue light has a greater frequency. C. Blue light has a greater energy. D. Blue and indigo light has the same frequency. Answer the same post-test questions in this Google form to know your score. Kindly visit the link below found on the description area of this video module. Thank you and congratulations! You have completed your Science 10 Quarter 2 Module 2 video module. You may watch this video once again, and if you want to go back to the previous topics or lesson, please subscribe to my YouTube channel for the next Science 10 Quarter 2 video modules. Again, thank you very much and have a nice day.